Let's have a look at what polygons are. So polygons are basically shapes but with straight sides. So I've got some quadrilaterals here, and there are two types of polygons. There are regular polygons and irregular polygons. So regular polygons, if we look at a square, a regular polygon, all the sides are the same length and all the interior angles are the same. So regular polygon, for quadrilateral that will be a square, so all the interior angles are 90 degrees and all the sides are the same length. An irregular polygon is one where we don't have that case. That is, we may have sides that are of different length and we also have angles that may be different. So irregular polygon. And here are a couple of examples here. So rectangle, you can see that we've got two pairs of sides that are of different length. So a rectangle is not a regular polygon. We've got a parallelogram here, and you can see that all the angles are not exactly the same. So this angle here and this angle are not the same. So a parallelogram is an irregular polygon. Now, just still looking at these quadrilaterals, if we want to have a look at what the sum of the interior angles are, from a previous video we know that it's 360, so the interior angles inside any quadrilateral sum to 360, add up to 360. But what we can do is we can split up polygons into triangles. So if I look at this rectangle here, I can actually divide that rectangle into two triangles. And then when I add up the interior angles in both of these triangles, so if I'm looking at, say, triangle number 1, this angle plus that right angle plus this angle here, if you add those three angles up, you get 180 degrees. If I look at the second triangle, so call that triangle number 2, this angle here plus this angle plus that right angle there also add up to 180 degrees. And if we are to add those two numbers there, we get 360 degrees. And just using that same color blue, if we go back to looking at the rectangle, this angle plus this angle here plus this one and then plus that one equal 360. So you can see that if you split up this rectangle into two triangles, we know that the interior angles in a triangle add to 180. Then what we're doing is just adding the interior angles of both those triangles. So 180 plus 180 is 360. Let's have a look at a pentagon to see this concept a bit more clearly. So again, you can have either a regular polygon or an irregular polygon. So if we look at this example here, this is a pentagon, pent meaning 5. So this is a regular pentagon. All the sides are of the same length, that is why we have these symbols here, and all the interior angles are exactly the same. As opposed to this pentagon, which is an irregular pentagon, because you can see that the sides are of different length and also the interior angles are different as well. So that would be an irregular polygon. If we have a look at the regular polygon, and we're going to split it up into some triangles. So the way you do this is you take one vertex, so if we take this one there, and just draw triangles from that vertex. So I can form a triangle here. So here's one. Go back to the original vertex and draw a straight line to an opposite vertex. You can see I've formed another triangle here and a third triangle there. Now what we know is that the interior angles of a triangle add to 180. So if I'm looking at triangle number 1, I know that this angle plus that angle there sum to 180. And if I look at triangle number 2, so triangle number 2, the three interior angles would be that one, this one here, and this one. So again, that would sum to 180 degrees. And the third triangle, I'm looking at the interior angles, this angle plus that one there plus that one there, sum to 180. So from the rule in the previous example, we know that if we add the interior angles of those three triangles, we will actually get the sum of the interior angles of that pentagon. So I've actually got three triangles here. So the sum of the interior angles of a regular pentagon is equal to 3 times 180. So 3 times 180 is 540 degrees. So if you were to add the 5 angles, so 1, 2, 3, 4, 5, if you were to add those 5 angles, you would get 540. And because this is a regular pentagon and all the interior angles of a regular polygon are the same, if I take that number there, 540, to find out what one of the interior angles is, I would need to divide that by 5. So if I divide that by 5, I get 108 degrees, which means one of those interior angles is 108 degrees. Actually, every interior angle of a regular polygon is 108 degrees. So you can apply this rule, the rule of finding out what one of the interior angles is. You can apply that to any regular polygon. Let's have a look at another example. So we've got a hexagon here. So this one would be a regular hexagon. This one would be an irregular hexagon. And what you could do is pause the video now and see if you can work out what the size is of one of those interior angles for a regular hexagon. So what you would have found with this regular hexagon is that you can split it up into 4 interior triangles. So the sum of the interior angles of a regular hexagon would be 4 times 180. So 4 times 180 is 400 plus 320. So that equals 720 degrees. So now, because we have 6 interior angles, if we take this 720 degrees and divide it by 6, we will get the size of one of the interior angles. So 720 divided by 6 gives me 120 degrees. So one of those interior angles is 120 degrees. One last thing to do with polygons is to look at something called the exterior angles. Exterior angles. And I'm going to use this irregular hexagon here. So what I want to look at is if you take one side, so if I take this side here, and what I'm going to do is just extend that side out like that. So it's a little bit wobbly line, but just imagine that's a straight line there, so you're extending that side out like that, and going anti-clockwise I'm going to extend all the sides. So extending all these sides like this one, and you should have 6. So this angle here would be called the interior angle, and its exterior angle would be this angle here. So that angle would be the exterior angle. Okay, so this would be the interior angle, and then extending that side out, this would be the exterior angle. So all these angles here are on the exterior of the polygon, so they are called the exterior angles. Let's have a look at a regular octagon. So this is a regular octagon, and we're going to have a look at the interior and exterior angles. So if I just split up this octagon into a series of interior triangles, so I'm going to start at that vertex there. Okay, so I've got 1, 2, 3, 4, 5. So 5 diagonals, and I end up with 1, 2, 3, 4, 5, 6 interior triangles. So the sum of interior angles is equal to 6 times 180. So that gives me 600 plus 480, which is 1080 degrees. So if you add up all these interior angles here, you will get 1080 degrees. So one of the interior angles would be equal to 1080 divided by 8. So let's just quickly grab our calculator and do that calculation. So 1080 divided by 8 is 135. So one of the interior angles will be 135 degrees. Now let's extend out one of the sides. So if I'm looking at this side here, I'm going to extend it out this way. I do know that the interior angle is 135 degrees, which means the exterior angle, because this is a straight line here, if that's 135 degrees, then that angle there, to make up to 180 degrees, because angles on a straight line add to 180, that will be 45 degrees. And if you were to extend out all the sides, so we're moving in this direction here, okay, you'd get 45 there. Extending this side out, exterior angle is 45. So you're going to end up with 8 exterior angles, each of them being 45. So if we add up the sum of exterior angles, that would be 8 times 45 degrees, and that is equal to 8 times 40 is 320, plus 8 times 5 is 40, so that equals 360 degrees, which is interesting. What you will find is that if you were to do this exercise for any polygon, you will find that the sum of exterior angles will always sum to 360. So what you could do is have a go at drawing a polygon and actually testing this concept.